Hello and welcome back to Dr. Logic Awkwardly Does Logic in her office. Today we're going to have a little bit of fun because I'm going to teach you how to do parse trees. Parse trees are a way of looking at a complex propositional logical formula and breaking it down into its subformulas so that you can see how all of the bits fit together. Now, parse trees are the sort of thing where if I give you the formal definition, they seem opaque and confusing and kind of scary, but when I actually draw one, you're like, oh, that was easy. So I'm going to give you the definition, but I'm going to kind of give it to you in the abstract, and then we'll actually talk through the bits as we go through a particular example. So parse trees are composed of three parts. There's the root of the tree, there are the leaves of the tree, and then there are branches. That's why we call them trees. The formula that we want to parse is always going to be the root. And then we have a series of steps that we do depending on what type of formula is in the root to decompose it, to create new branches and new nodes, we will call them. So parts of the tree, both the root, the leaves, and everything in between are called nodes. So I will tell you at each stage whether you need to create new branches and new nodes, how many, and what should go into them. So basically, our atomic formulas are always going to be the leaves of our tree. Once you've gotten to the atoms, you can't get any further. So if you start off with a node, that is an atom. So if your root is an atom, then you don't have to do anything. Your root is also a leaf. You don't have any branches. So nothing more occurs if your starting formula is already an atom. If it's not, then, if it is a negation, so it's of the form not phi, what you will do is you will draw one branch and you will draw phi at the top. And then you ask yourself of this new node, is this a leaf? Is it an atom? Or is it itself a complex formula? In which case, you go back and you apply the algorithm again. So the other options that we have for non-leaf, non-atom nodes are if they are either conjunctions, disjunctions, or implications. In those cases, what you will do is you will draw two branches, and you will put each conjunct on a branch, or each disjunct, or the antecedent on one branch and the consequence on the other. Then you've kind of built up a stage of your tree, and you go back across and you look at each of the nodes and you ask yourself, is it a leaf? If it is, you do nothing. If it's not a leaf, what is the connective? How do you decompose it? So this will keep going and going and going until you reach a point where all of your nodes are leaves. And because all of our formulas are finite, so there is a fixed number of connectives and atoms that occur in them, this process will always terminate. So let me bring up my whiteboard so that I can show you an example of what such a parse tree and such a method for making it looks like. So down here at the bottom, we will have our, there we go. We'll have our complex formula, and it's going to be quite a nice one. So not P, or parenthesis, Q, arrow, parenthesis, R, arrow, P and Q, and then the bane of the logician, making sure you close all of your parentheses. So 1, 2, 3. This is the root of our tree. Is it an atom? No, it's not. It has logical connectives in it. So we need to find out what is the main connective. And I said in my previous video that you're going to need to know what your main connectives are because you can't apply certain rules if you don't know what they are. Here, the main connective is the one that is within kind of the fewest number of parentheses. So in this case, it is the disjunction. So we draw two branches and we put the left-hand disjunct on one and the right-hand disjunct on the other. Now we have a bunch of new nodes to look at. So let's take a look at this one. Is it an atom? No, it's not an atom, so it's not a leaf, so we need to be able to decompose it. What is the main connective here? It's the negation. So negation says you take one branch and you put the formula without the negation, the subformula, on the end of the branch. Now, if we look over here at this one, is this an atom? No, it's not an atom. It's a very complex formula, and the main connective here is the arrow, the implication. So this means we have another binary branch, get two of them coming from this node, at which we put the antecedent on one and the consequent on the other. Look at that, we've built another level of our tree. Let's go all the way over to the left-hand side. It makes sense to work through these systematically. And look here, is this an atom? Yes, it is. Hurrah, it is a leaf. Let's make it a nice autumny fall holly leaf. Move over to our next node. Is this an atom? Indeed, it is. Let's give it, I don't know, elm. I think that's sort of like an elm. Moving over here, ooh, this is not an atom, so we are not at a leaf. We're at another place where we need to branch. What is our main connective? It's the implication. So we split our tree into two. We put the antecedent on one branch and the consequent on the other branch. And now we can go back to look at our leftmost node. Is this an atom? Yes, it is. So we have another leaf here. Let's try to do there, a little linden leaf. Moving over to our next atom. This is not, our next node, because this is not an atom. It's a conjunction. The main connective is the only connective, but it's a binary one, so we branch again, and we put P on one side, Q on the other side, and these are both leaves. We'll make them holly leaves again, because I'm not entirely sure that I could do, say, oak or maple with a little stylus on an electronic whiteboard. But there you have it. Isn't this a beautiful, very colorful, very festive little tree? So you don't really need to know how to do parse trees in order to be able to do propositional logic. But if you are ever uncertain of how bits and formulas fit together, or what the main connective is, or what the atoms involved are, or what the subformulas are, this is a good way of kind of going through and decomposing a formula so that you can see what all of the parts are. So if this here is our main formula, our well-formed formula, then every single one of these other parts, so not P, P, Q, this big long implication, this implication, R, P and Q, P, Q, these are all subformulas of this main formula. So I said in the previous video that the subformula of a subformula is a subformula of the main formula. That's all that I meant. I meant that every single thing that you write down at one of the nodes of your parse trees is going to be a subformula of the formula that you started with. So there you have it. Parse trees, loads of fun, a useful way to really cement the idea of main connective, conjunction, disjunction, implication, antecedent, all of these vocabulary things that we've introduced. But if you're already comfortable with all these notions, you don't really need to learn how to do parse trees. They're just a bonus. Next time, we will move from questions of language to questions of semantics. So starting to put meaning into all of these different constructions that we've built up. So I look forward to seeing you then. Cheers.